Hi there, welcome to section 1-4. So geometry chapter 1, section 4, more terminology, so bear with me on this. We've talked about points, lines, and planes. We've talked about segments, has two endpoints. Array is in the same situation as lines and segments. A ray is a part of a line. It only has one endpoint. We can't get a measurement for array, but it's got one endpoint and then it goes off in one direction forever. So we name this, using the endpoint. Let's do it this way. We name it using 2 points with a ray above it. And I want to make a note, 1 point must be the endpoint. When we named a segment, we named it by the 2 endpoints with a segment above it. When we named a line, we named it with 2 points on the line with a line above it. Well, when we name an array, we've got to use the endpoint and another point. So I could name this ray, ray EG, or I could name it ray EF. Sometimes people ask, could I name it FE if I wanted to? Well, you could. It all depends on how you put that ray above it. If you wanted to name it FE, we still have to know that E is the endpoint and it keeps going past F. I think that looks weird. I prefer to put the endpoint first and the point after that it keeps going. Opposite rays are kind of a funny, interesting thing. They are 2 rays that share a common endpoint. And, shockingly enough, they go in opposite directions. Therefore, they look like a line. It's kind of one of those technicalities. Instead of saying that example is line QR, we could say ray PQ, that was supposed to be a Q. Ray PQ and ray PR are opposite rays. The only reason you need to know that is because they often use that in directions instead of saying Q, P, and R are collinear. They might do it that way. So opposite rays, it looks like a line. And then the biggest thing out of this section is angles and how to name them. We're going to do a lot of practice with that. Angles, we all know what an angle is, right? An angle is technically formed by 2 rays with a common endpoint. So I could say, oh, I should say this too. The common endpoint is called the vertex. Hopefully you know that term. The vertex is the point of an angle. If you look at the diagram in the center, it says vertex A. Notice it's got side AB. This is a ray AB and side AC. It's actually a ray. When you name an angle, you name it as with the angle sign. So the angle sign looks like sort of like an L. It's not a less than. It's a little more, but the bottom is more horizontal. So we name it angle, whatever it might be. I'll say 3 points. But there's fine print in here. The vertex must be in the middle. It's wrong if you call it something else. So if I wanted to name this angle, I could name it angle B. A is the vertex in the middle, C. Or I could name it angle CAB. Either way, the vertex A is in the middle. If you named it BCA, that would be marked wrong. That's not right. Angle BCA says that C is the vertex. Well, the common endpoint, both of those rays shoot out from point A. The other way that you can name this angle is if they give you a little tiny number inside the vertex. So right here, you could also call that angle 4. Be careful though. angle with a number. That's not a hashtag. Be careful though, because sometimes that number might be at degrees. So you have to just be watching and seeing the context of it. If you're in doubt, if you don't know if that's a good number to use, then use the points and put the vertex in the middle. So again, the biggest thing in this section is seeing what an angle is, identifying it, naming it, and being able to use those. So interior and exterior, everybody knows these terms, right? You know what interior is. Interior means inside. So if I was talking about angle MP, whoops, I wrote it wrong. I said it right. MPR. I'm going to highlight angle MPR. P is the vertex, so everything shoots out from P. So there's angle MPR. If I asked you for an interior point, it doesn't matter if there's a ray attached to it or anything else. Angle MPR, interior point would be angle N. It's in that highlighted part. Exterior means outside of an angle. So if I'm still looking at MPR and I said, name a point that is exterior to angle MPR, you would probably tell me angle L, because it's outside the angle or not inside that highlighted part. Oh, did I say angle? Those should be points, right? Point N. Whoa, point N. I got stuck on angles for a second. And point L is exterior. We use that in word problems sometimes. So, all right, so here we go. It says name all the angles that have B as a vertex. So first of all, B is a point. We have to identify it, find it. Point B happens to be right here. I don't know about you, but I see four angles that have point B as a vertex. You can name them, remember, with numbers or with 3 points. So maybe you said that angle 7 has B as a vertex. Remember, B, the vertex is the point at which the 2 rays come out of. So I could name that angle 7, or I could name that angle ABD. B has to be in the middle. It'll be wrong if it isn't. I also see this angle up here. This one usually people save for last, but since I'm in charge, I'm not going to. That doesn't have a number in it, so I have to name it with 3 letters. Vertex in the middle, so angle GBA, or I could name it ABG, as long as B is in the middle. I've also got this angle down here that has B as a vertex. So perhaps you would take the easy way and call that angle 5. If I asked you not to use a number, you might call that angle GBE. Or perhaps GBF. Those would both be right. Notice there's a difference between GBE and GBA because it gives you a different direction. They both have a ray in common, GB, but the direction after that changes. And the last angle that has B as a vertex is the one that's unhighlighted. It is this guy. Oops, I already used green. It is this guy right here. And it has an angle 6 if you were going to do that. Or perhaps you would call that angle DBF. If you called it DBE, you would also be correct. So 4 angles that have B as a vertex. Then it says in letter B to write the sides of angle 5. Well, remember, sides are, I'll just take these out of here. Sides are the 2 rays that form the edges or come from that common vertex. So I'm going to ask you this question in some work, so I want to make sure that you know exactly what it is I'm asking for. So the sides of angle 5, right, this is angle 5, this highlighted spot right here. So it comes from B and goes out that way. That's one of our rays or our sides, and then from B in this direction. So sides are rays. So we could say that ray BG, and I'm going to label that appropriately. B is the endpoint. It goes past G. And the other side would be ray BE. Or if you wanted to call it BF, either one would be correct. And then letter C, we already wrote another name for angle 6, so we're good there. All right, so identifying angles, rays, vertexes, and labeling them. I think I've said it 4 times now. Classifying angles. This is short and sweet. Everybody knows your right acutes and obtuses, right? So let's take a quick minute. So right angle means what? It equals 90 degrees. It's nice and square. If I were to make a model, I would draw. Please make rays on both sides. The vertex is where those 2 rays come out of. And even if you're a terrible angle drawer, how do you know that this is a 90-degree angle? Label it appropriately. Put the right angle box in there. Acute means less than 90 degrees. So if I'm going to make a model, I'm going to do the same thing, put that. However, actually, maybe I should make this dotted. That might be smarter. I'm going to do this. There's my angle, and then I'll do that. There's a right angle, and my dotted line is showing where 90 degrees would be. My solid ray in the middle is showing what acute angle I'm looking at. So that might be like 50 degrees or something like that. And last but not least, obtuse is our only other choice. It's got to be greater than 90. It's actually less than 180. I didn't put that in there. So I'm going to do the same thing. I'll make where 90 degrees would be, and then I'll make my obtuse angle going like that, larger than 90. Everybody knows those. Hopefully that was just a quick review. All right, I think we can jump over this. Let's go to congruent angles. So we talked about congruent segments, segments that are equal or have the same measure. You might be shocked to learn that congruent angles are angles that have the same measure. The symbol is still the same. That would be a equal sign with the little squiggle on top. We're going to use that a lot. So we're using the same concept, applying it to segments and to angles. It's the same yet different, if that makes any sense. So probably you notice immediately in this diagram that this is 25 and this is 25, right? So we're going to be able to say that angle, what's the vertex of both of those angles? We need to make sure the vertex goes in the middle. So if I ignore this part of the diagram for just a second, what is that angle? How would you name it? I would probably name it as angle NMP. M is the vertex in the middle of that, where the 2 rays come out of. And what is NMP congruent to? They're both 25 degrees. So the other angle, I would probably name it as angle RMQ. If you named it QMR, you would be right. I'm going to look to make sure that M is in the middle of both of those because M is the vertex. So we've got 2 congruent angles. What if I didn't tell you that they were 25 degrees? You might catch on really quickly based on our conversation with segments. Segments have dashes. Congruent angles, we put a little arc in there. So those also mean congruent. So even if I don't tell you the measure, I may say just those 2, there's your diagram, tell me what the angles are that are congruent. You will know that they're congruent based on the diagram. If I've got more than one angle, they might do a double arc or a triple arc or something like that. Sometimes the geometry book has pretty easy concepts, and then they put this convoluted diagram in there, and so you have to be looking for single dashes or double arcs or things like that. So let's talk about an angle bisector. We talked about a segment bisector. A segment bisector goes through the midpoint of a segment. An angle bisector goes through, we don't really call it a midpoint, but it's a ray that divides an angle into 2 congruent angles. So I would be able to say in this diagram, notice I've got these 2 arcs right here. They kind of offset them so it doesn't look like one giant angle. I would be able to say that PQ ray PQ, I messy Q's, ray PQ, I got this, last try, there we go, ray PQ is an angle bisector. I use the angle symbol and then BIS for bisector. If you want to write it all out, feel free to do so. And I can see a math problem coming along because I might say something like, oh, well, angle RPQ is 3x minus 7. And angle QPS is 2x plus 17. Solve for x. Well, if we know that an angle bisector creates two congruent angles, we'd be able to say that angle RPQ is congruent to angle QPS. So we'd be able to substitute in 3x minus 7 and 2x plus 17. I don't know if you've noticed that I jump between a congruent and an equals. When it's congruent, I'm talking about the angles. When it's equal, I'm talking about the algebra problem. Notice there's still a geometric statement there, and then I substitute in the algebra. All right. So I feel like we could do one problem. Let's do problem number 4. So again, remember I said geometry, a lot of times they do crazy things, like they ask you to go one step further instead of just saying x equals like we do in algebra, or they put stuff in the directions. So in the directions, I see this. QS bisects angle PQT. Well, angle PQT, I'm going to highlight just so you can see it. P to Q to T is this. If QS, this ray right here, bisects it, whoops, wouldn't you agree then that the two parts have to be congruent? So this has to be congruent to this. That's what an angle bisector does. They don't use angle bisector, but they use the word bisects. QP and QR are opposite rays, which just means that they form a straight line. So it says, if angle P, in number 4, if PQS is equal to 3x plus 13, PQS is this smaller part right here, 3x plus 13. SQT, the other smaller part, is equal to 6x minus 2. I might have talked you through this problem. Find the measure of angle PQT. We probably should circle that so we forget to not stop after we find x. So if those two are congruent to each other, we can say that angle PQS is congruent to angle SQT, which means we can substitute some values in there. 3x plus 13 is equal to 6x minus 2. Don't you just love doing algebra? I'm going to subtract 3x here. So that's going to give me a 13 equals 3x minus 2. Solve this equation whatever way you want to. I always do the variable first. Other people do the numbers. Whatever. 3x equals 15. So would you agree that x is going to have to be equal to 5? But that's not what it asked us to find, right? It asked us to find PQT. PQT is the whole angle. So I feel like if we knew each part, we could add those together. And hopefully you recognize that each part should be the same value. Built-in double check, it's always there in geometry. So if I put a 5 in place of this, 3 times 5 is 15, plus another 13 is 28. So this should be 28. Now you might just be like, oh, well, the other part has to be 28, but I like to double check, make sure I did my work right. If I put a 5 in here, 6 times 5 is 30, minus 2 is thankfully 28. So angle PQT must be equal to 28 plus 28, which I believe is 56 degrees. So there's some sneaky problems. I'm going to tell you to draw diagrams. Please draw diagrams. It helps label, highlight, whatever you need to do. I do a lot of highlighting when we do these problems, especially at the beginning so you can see them. That is it for section 1-4.